All right, good morning. Well, we have a couple extra sections that are kind of tying in to what we're learning about with algebraic expressions, and these are out of the blue book, which is more for the advanced class. That's why you guys are going to have two extra sections in talking about algebraic expressions. And so this section is all about gathering like terms, okay? And so on the sheet there, I've defined what like terms are, and that like terms are the same variables raised to the same exponents, or that they are the same like type of numbers. So for instance, numbers like 5 and 1.8 are constants, and so they are like variables. Whereas if you look at the rest of the like terms up here, they all have the same letter, so therefore, and as well as the same exponent. They're all raised to the first power up there. So therefore, they are like terms. So in order for you to be able to gather like terms, they have to have the same letter, or they have to be a constant. And along with being the same letter, they also have to be raised to the same power. So if anything, if the x's were all raised to the second power, then those are like terms. But if you have an x squared and a y squared, they're different letters, even though they're raised to the same power. So you've got to make sure that they're raised to the same power, they're the same letter, or they are constant. Otherwise, they are not like terms. So you cannot just go ahead and add, subtract those together. Okay? So unlike terms, looking at the bottom, you've got these are x's, but there's an x squared and an x to the first power, so therefore those are not like terms. Okay? Now notice the like terms up above it. They're both x's, they're both raised to the first power, but they have different what are known as coefficients. Remember, a coefficient is the number that's being multiplied by the variable. So the coefficient here is a 3 and the coefficient there is a 2. Those can still be added or subtracted together. It's okay that they are different coefficients. What matters is that they're the same variable raised to the same power. Okay? So looking at number 1, you are supposed to identify like terms. So I'm going to identify them with different colors. All right? So looking at the x's, I'm going to underline with a red bar. All right? Here's another x, but it's raised to the second power, so it's not the same as that one. So 3x. All right? Y's are different letters, so therefore that doesn't work. 5 is a constant, so no variables attached to it, so it's not an x. Then you have 15x, and then that's it as far as the x's go. So looking at the y's, you've got y, 4y, 9y, and 9y squared does not work because it is raised to the second power instead of the first, so therefore you can't use that one. And then x squared, 3x squared, and that's it as far as the x squareds go. And then looking at the next thing that we have in common, we've got constants. We've got 5 and 17, which leaves us just with 9y squared as the lone like term as well. So we've identified each of the like terms. All right, and so if this was a problem and we were gathering the like terms and trying to condense them to where we didn't have so many of them, all the ones that had the same color or same number of underlines could be collected. So the x's that are underlined in red could be gathered. The y's that are green could be gathered. The blues could be gathered. The blacks could be gathered. All right? And then there's nothing to go with this y squared, so it would have just been by itself. Okay? So you wouldn't have gathered anything with it. All right? So in gathering like terms, looking at number 2, you have got to do the operation. As long as they're the same like term, you can do the operation and go ahead and condense this into some or simplify it. okay? So we're not going to find out what x is. It's not set equal to anything. So we're not finding what x is. We're just trying to simplify and gather like terms. So notice that this x, this x, this x, and this x all have different coefficients, but that doesn't matter, remember. It matters on whether they're all x's and all raised to the first power. And they are. So we can do this. 7 plus 3 is 10x. Remember to do PEMDAS in, all right? 10 plus 5 is 15x. And then 15 minus 6x is going to be 9x. So 9x is going to be what all of this turns out to be. Now, we don't know what x is. We don't care. All it mattered is that we simplified and condensed all of our like terms. And we only had one set of like terms. We only had x. Okay? Whereas number 3, we have to do something a little bit different. We can't gather like terms inside here, inside the parentheses. But what we can do is we can go ahead and do distributive property. 2 times a is 2a plus 2 times 2a squared. All right. So when we do this, we take 2 times 2, which is 4, and then a squared plus 2b. Now, can we gather any other like terms? We do have 2 a's, but one is a to the first power, one is to the second power, so therefore we can't do anything with it. And then we have a b, and no other b's to go with it, so this is simplified. This is as far as it can go. Looking at number 4, we've got x's, we've got y's, we've got x squareds, we've got x cubes. So we still need to simplify and get all of the like terms gathered together. Okay? So looking at this, we've got x cubed. And we've got 2 of them. So we've got 5x cubed plus 7x cubed. And we like to order them in the order that they are based upon the size of their exponent. So we start with the cubes. Then we have the x squared, so minus, because it's minus 4x squared, minus 4x squared plus 3y minus 2y. Now that we've kind of ordered it, it makes it a lot easier to be able to condense, okay? So once again, these are the only like terms that we can do anything with. There's no other x squared to go with. So we want to do 5 plus 7. Remember that you just add the coefficients because that's what you're doing. So that becomes 12x cubed, all right, minus 4x squared because there's no other x's to be able to condense. And then we do this operation, 3 minus 2, which is going to be just y. And since the 3 is bigger than the 2 and it's positive, that's why it's plus y instead of minus y. So 3 minus 2 gave us just y. You could put 1y, but that y is just kind of gratuitous. We don't need it. That's why it's just y. Okay? So now we have it simplified. We have no other like terms that we can do anything with. There's no other x cubes, there's no other x squareds, there's no other y's, and it doesn't matter that we don't know what they are. All we were supposed to do was simplify. Okay? All right, so go ahead and attempt the practice problems. All right, see what you can figure out, and then we will come in tomorrow and I'll take any questions. Thanks.